Hi YouTube. Project is to move a stepper motor with an Arduino and to control the stepper motor with two buttons. Two buttons. One button is let's go and the other button is let's go backwards. So and basically we're running a large stepper motor with a lead screw attached to it, which I don't have that set up here. Okay, so what I'm going to do today is show you my setup. Okay, here's the code, and here's the stepper, and here's the setup, and here's the control box I yanked out of my CNC in the garage. Let's start with the code.
We need a few integers to make sure we have inputs and outputs to the Arduino. So let's just start with our move button. We have a move button that we push and things move. That's a constant integer. And then we have the state of that button. Is it pushed or is it not pushed? So we're going to pin 2 on the Arduino, and is it pushed or is it not pushed? Constant integer is pin number 4 is the direction button. And is it pushed or is it not pushed? And I'm using direction signal state. Is it pushed? Is it not pushed? Its default is not pushed, or 0. Constant integer is the direction signal. This is an output signal, and we're going to send it to pin 8 on the Arduino. And we're going to connect the pin 8. This will be connected to connects to the dir plus or CW plus on driver. There we go. And then this is our move signal, and this connects to, this is pin 9 from the Arduino, and it connects to the, yes, so, and then this, so this connects to the pulse, so it's either PUL plus or CP plus on the large driver. And what that is it's a pulse plus is the signal pulse for moving the motor, should the motor move, and CP is control pulse. So that CP stands for control pulse. Pulse just means pulse. It's the same thing, and different drivers have either one of these. The DIR is direction plus, or some drivers have CW for clockwise plus. And you'll have a CW plus or a DIR plus and a DIR minus or CW minus. The minuses, they go to the ground on the Arduino. So, and you'll see that in the wiring setup. Okay, so we've got this set up. In our setup here, we want pin mode. We're declaring what the pin's doing. Move button. The move button is an input, and move button is hooked to the pin 2 on the Arduino, and that is a digital pin 2, not analog. So digital pin 2. And then we have the pin mode, and that's an input. Then we have pin mode direction button input, And direction button is pin 4 on the Arduino. Move signal is an output, and that is move signal is connected to pin 9, and direction signal is an output, and that's pin 8, and that's the connection set up there. We're going to digitally write as a default to direction signal as low, meaning there won't be a pulse, and digitally write to the move signal. So this is pin 8 and this is pin 9, and we're going to tell it that it's at 0 for both of them, or low, no pulse. Now we move down to our loop. We want move button state. Our variable of move button state equals digital read button of the move button, which is on pin number 2. Is that pushed? Move button state is going to say it is pushed or it isn't pushed. Same thing for direction signal state. So we're going to read is at the top end of the loop. We're going to read each time, is this button pushed? Is that button pushed? This is the button connection. Direction button is pin 4 right here, and the move button is pin 2. And you'll see how to set up the breadboard. Now what we want to do is so we are reading the state of those two buttons. So if the move button state is depressed, is pushed, yeah, I don't know why this works as 0, but it does. If I change it to 1, then it will always move the motor. I'm not sure. But anyway, run it like this. If you know why, tell me. But if the move button state is 0, then so if the move button is pushed, we can have two conditions. We can have it pushed with the forward motion, or we could have the other button pushed as well, the direction button pushed, and then we want a reverse motion. So if the move button is pushed and the direction signal button is not pushed, that means low, then we want to send a signal. We're going to digitally write send signal to the direction signal and make it high. We're going to send that pulse because we want it to move forward. And we digitally write move signal high because we want it to move. And then we're going to wait only 10 seconds. This is the reverse. This is where it's reversing in high speed. And then we're going to wait 10 seconds, and then it's going to shut the signals off. And then it's going to skip this whole period if you're still pushing the button. And it's going to loop back up until until these buttons aren't pushed. So it'll keep going through this period of the cycle, and it will move in this way. If the button is pushed for moving and the direction button is not pushed, then or the direction button is pushed, then you'll get this. No, if the direction button is not pushed, you'll get this, and it'll wait longer, so you're turning slower. Okay. So if the button is pushed, you get one of these two. That's the move button. If the move button is not pushed, that's this else. Any other condition in a Boolean is else. So then nothing's going to happen. So this loop will continue to run And if you don't push a button, it will constantly default to here and there's nothing to do. So, all right, I hope that helps, and stay tuned for the rest of the video.
Your stepper motor will have leads on it. Generally they're green, yellow, blue, and red. And I have connected it with these trailer connectors, 4-prong connectors, so it's easy plug and play. That comes up into my box and that goes to this. It only uses one of the stepper drivers. Here is how it connects to the stepper motor. So on my stepper motor, this lead, which is white, I have drawn red ink on this with a red marker, but my white lead goes to my red lead down here. Like if there's a color that starts with the same letter, so blue, brown, B, 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 B. Alright, so, and if you look at the brown lead here, and then you go down here, brown goes to blue, red to white, green to green, yellow to yellow. And that goes right into there. Okay. So then, on your A plus signal wire is right here. On the A plus, we have red. A minus is green. B plus is yellow. B minus is blue. So, but you would put the blue lead here if you were running just the colored wires or the stepper directly to your stepper driver. Alright, here we have our volts in. In this case, I'm running 24 volts from my power supply. And then we've got ground is the white wire behind here. So volts in and ground, red, green, yellow, blue. Alright. You take your blue wire from your power supply and you go to power, and then you run your white wire from your ground, the negative on your power supply. Here is the button to move the motor, and here's the button to move the motor backwards. In this code, if I want the motor to move, I push this button, and then if I want the motor to move backwards, I push both buttons. So I'll push this one, it's running that way, slow, and then I'll push the other button while simultaneously pushing the other one. And now it'll go backwards. Forwards, backwards. Forwards, backwards. On a breadboard, all these are connected in that line. So if I plug in this here, it is connected to this prong on a button, my 10K resistor, and that's connected to that prong of the button. And then this lead is connected to this yellow wire going to pin number 2. Alright, and then this lead goes to my negative bar. Now the negative bar is connected all the way along, and then my positive bar is connected all the way along the whole breadboard, all the way. So to this side of each switch we need power, so that's here coming from the power side, this orange, and then we need negative to this side of the switch, and that comes from my negative. Now you can put it in any one of these, I just stretched it out so it's easier to get to the buttons. And then again, on this side we want power in. It connects with this, so this is in line with the resistor, 10K resistor, and that comes from my power board, the power strip. It's tucked in here behind. There you go. And then this is my negative, which goes to here, and that's that side of the switch. And then this pin goes up and over into my number 4 on the Arduino. So if you're following the code along, you'll see that that is the button direction state. What did I call it? I called it there we go. So number 4 is direction button, number 2 is move button, direction signal is 8, move signal is 9. Okay, so one other thing to do on the board here, we have to connect to the ground on, this is our negative minus strip all the way along. This wire comes back to a ground on the Arduino. And then the 5-volt green there, this one, goes to the plus side of the breadboard. So this one is essentially powering this one and this one. Okay. So if you had noticed on the code, I am using pin 8 and 9 to control the motor. So let's look at my motor signal pulse sends a command when it is in a high state, which means on. That sends the electrical signal from the Arduino to my CP plus, which is the yellow. That's CP stands for control pulse, and that goes to here. So pin 9 is yellow right here, goes to CP, control pulse. CP negative will go to ground, and I have it on this green wire coming back up here to ground. And that's the goofy one hanging off there. And then I have my CW, which is the direction, and I believe this stands for clockwise, and CCW would be counterclockwise. But in this case, it's either, if it's a positive, you get clockwise rotation. If it's a negative, you get counterclockwise rotation. So that is this orange lead, and that goes up to my pin 8 on the Arduino. There we go. Pin 8 to clockwise plus. Now clockwise minus needs to go to ground, and all I've done is simply taken the clockwise minus or ground wire and jumped it over to my control pulse negative as well. The white gets its ground through the green here. I have used this setup where these are different labels, but essentially you'll have DR plus, DR minus, that's your direction. You'll have pulse or PUL, positive, negative, whatever they say. It's just, you have the pulse means go, direction means which direction to go. And here you just have one input here for yes, go ahead and move, and here yes, turn clockwise, no, turn counterclockwise. Those two connections, we will be able to run this motor. I had some confusion in the beginning because what stepper motors do, bipolar stepper motors do, is they split up A and B pulses so that it has great control between two stators. I'm not sure exactly what it is in the motor, but this allows it to step. Now, I thought I had to send two different signals for A and B to this unit, but I don't. I just have to send a go unit, and then this thing separates the signal to power the motor appropriately. Alright. On my setup, These dip switches are set to 1/16 resolution, and if you're getting into this, you'll notice the chart over here. So 1/16 would be 0, 1, 1, 0 for switch 5, 6, 7, and 8. So 0, 1, 1, 0. 0, 1, 1, 0. And then this is set up for 2 amps. Alright, and you can follow that on your dip switch settings for switch 1, 2, 3. And then notice here, a lot of times your switch 4 will determine if you're half power or full power. So I'm running this at half power, and or maybe full power. 1, 1, 1, 1, 1. Huh. No, 0, 0, 0. I'm at 2 amps. Anyway, doesn't matter. You figure out that end of it. Play around. If you see a puff of smoke, turn it off. Okay, so what we end up with is this.